All right, here we go. 18.3, second time around. Now we finally have audio this time. So starting on page 488, talk about current and future trends and impacts. So first off, extreme weather is becoming more and more and more frequent, both around the country. Think of like the wildfires that are occurring more and more often in bigger states, or excuse me, in larger states, there's bigger fires. But think around the world as well, you know, like the hurricanes and the tsunamis that are happening around the world as well. There's lots of research that has been conducted about all of this kind of climate change and increase in weather events and so on, a whole bunch of research, which has led to this thing called the IPCC, which you can see just below the sticky note there, is this Intergovernmental Panel on Climate Change. So basically, they're the ones that kind of have compiled all of that research together. So rather than just kind of it being kind of across the world in different universities, it's all kind of compiled into one specific place. Now, 489, the thing I wrote there is be able to use these examples. So this picture here I like a lot, actually, because it talks about a whole bunch of different things that are going on. You can talk about the average surface temperature has risen. You can talk about precipitation is increasing. Heavy precipitation events cause flooding. Arctic sea ice, as its summer minimum, has thinned. Basically, it's melting. The Arctic is warmed faster than other research, and there's just like a whole bunch of different examples. So your ability to be able to cite these is a very, very, very good thing. So basically be able to have more than just, well, it's warming, like have specific examples of what climate change is doing to impact our world. The science behind the story here talks about how climate models work, which is pretty good kind of information to know and be able to regurgitate as well, kind of explain how those climate models are working. So now we're on 492. So basically, they talk about temperature is continuing to climb. So it has risen 1.1 degrees Fahrenheit or 1.1 degrees Celsius, 2 degrees Fahrenheit in the past 100 years. If you were born after 1985, you've never experienced a month with cooler than average global temperatures. So you guys have never experienced in the world a month with a cooler than average global temperature. That means since you've been alive, the Earth is just continuing to get warmer and warmer and warmer and warmer. Every single one of the months is above average. So in the US, most places have risen by more than 1 degree in the last 20 years. So these charts here are showing basically what I just talked about. Global temperature measured since 1880. So you can see this 1985. You can basically see how it's just below average, above average. You can see northern hemisphere temperature the past 1,000 years, kind of hovering around, and then all of a sudden it's skyrocketing right now. Here around the United States, you can see the temperature change. So like the really dark red areas, like think of Alaska, you know, think of southern Nevada, southern California. Those areas, basically their temperature change has been above 1.5 degrees. But you can also see it's getting a lot cooler. Like think of this, like Alabama and the panhandle of Florida down there. That's starting to get cooler as well. So basically there's dramatic changes as occurring. So here we are on 493. So precipitation changes as well based on climate changing. So a warmer planet leads to more evaporation, but an uneven spread of the rainfall. So, this chart down here is talking about the precipitation changes. So you can see you got 10 to 20% decrease. So you can see basically kind of like right along kind of the 30-degree south latitude there, it's decreasing. But look at like how much where it's increasing. Right along the equator right there, okay? The precipitation is really vastly increasing in the northern Arctic as well. So that's what they're talking about. So a warmer planet leads to more evaporation, but an uneven spread of rainfall, like I just talked about. So more extreme weather makes increase in damages more, and we're talking about money as well, which makes higher insurance costs. So if you live in an area where the weather is getting more extreme, think of like southern Florida with all the hurricanes down there. If you live in that area, your insurance costs are starting to rise dramatically And there are certain places the insurance companies just won't protect you because they know the amount of money it's going to cost to replace things is going to be more than what you paid in. So it's not a good business decision for them. So going to 494 now. So we're moving on to changing jet streams. These also make weather more extreme. So first off, what the jet stream is, typically it looks like this. Okay, you can see basically Washington's right there. You know, you got DC right over here. Kind of goes up and it kind of comes down. And basically this kind of is the normal amount. You see weather systems move west to east at a normal rate. But an abnormal one, like what happened in March 2012, it becomes really looping. It kind of goes real up and down farther. So the problem with that is since it loops more, it takes longer to cross the continent. So we get really, 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 really cold weather for a longer amount of time. They get really, really, really hot weather for a longer amount of time. Like the big storm that just happened in Texas, one of the reasons is that this polar vortex basically started dropping down here. This jet stream started dropping down on kind of like encompassed all of Texas. So that cold weather basically pushed down into Texas and froze everybody. That's kind of the issue that's going on. So the changing jet streams also make weather more extreme. So the rains will last longer. Obviously, that will lead to flooding. The dry conditions will last longer. That's going to make a drought. Then we also have melting ice problems. So melting ice provides us with lots and lots of drinking water. So if we aren't getting as much ice in the mountains, think of Seattle and the Western Washington as an example. If we're not getting the ice in the mountains, we're losing our drinking water supply. Then the melting ice is also going to rise sea level. They talk about the West Antarctic ice sheet. If that whole thing melts, sea levels will rise 3 meters. That's over 9 feet. The other issue, less ice, less reflectivity. So the solar energy that's coming in, if there's a lot of ice, it basically is kind of like pushing it back out into space like a big mirror. But if there's less of it, basically there's not as much pushed out of our atmosphere, so it stays here. Also, ice holds a lot of methane. If we release a bunch of methane, methane is a much stronger greenhouse gas than CO2. It warms our planet even further. So here on page, what page am I on now? 495, it's just kind of a picture of some glacier in 1911 and then in 2009. Just look at like the difference of this area. It's crazy. In the Glacier National Park in Montana, 25 of the 150 glaciers at the park's inception have been lost. 25, or excuse me, only 25 are still there. And scientists are estimating that in the next decade or so, we're going to lose even more than that. So we're losing a ton of them. So you can see in the chart right there, the world's glaciers are shrinking. You can see just the amount of them is just declining big time. Then the global sea level rising, you can see that is also increasing. So as ice melts, it gets into our oceans, pushes the oceans higher. I actually just watched Waterworld the other day, so it makes a lot of sense. All right, this picture here, this image here, hint, hint, maybe on your test. This was on an AP exam in 2016, 2017, something like that. So what this is, basically the arrows are showing sea level trends, like it says right there. Basically, sea level is rising, sea level is rising. Basically, look all over the East Coast, everywhere is rising. So you can see along the West Coast, rising, 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 rising. There is a falling sea level right there, falling sea level right there. But overall, sea level trends, everything's rising, which is bad news because some of the, like you can see like the capital of the Maldives there. The Maldives is a whole big string of islands. And as sea level rises, it just literally is going to start just engulfing these islands. So one of the things that the president did, which I think is actually a really cool story, he took his whole cabinet meeting and they held a cabinet meeting underwater to demonstrate to the international community, like, hey, we need help. Like, if we don't do something, if you guys don't help us out, we're literally going to go under. And some countries have actually started purchasing land on like mainland China and India and places like that to basically make it a place for their citizens to go. Pictures down here below talking about hurricane or the superstorm Sandy, basically taking over New York City. Like you can see a whole bunch of flooding for the of the taxi cabs. Shoreline homes are toppled by the storm surge. The whole neighborhood caught on fire there. Like there's a whole bunch that went bad with that storm. So 498, what I wrote here is that the IPCC, it predicts a 10 to 32 inch sea level rise by 2100, like we were just talking about. But new research suggests that Greenland's ice sheet is melting. That's going to accelerate that. So their prediction didn't take into account how quickly Greenland's ice sheet is melting and continues to speed up melting. So major U.S. cities are going to be impacted. Think of Miami. That's definitely going to be hit the worst. And this image up in the top corner here really demonstrates that. So sea level rise scenarios. So 1 foot rise, 2 foot rise, 3 foot rise, and so on. So if you go 1 to 3 feet, we're basically wiping out a lot of Miami's literal and money makers for their city and for their state. I mean, it's just going to get wiped out because of it. Another thing, ocean acidification. Now, I do want to point out, this is not actually turning the ocean into an acid. One of the things that they kind of I don't even know, more of a correct term, maybe that might be a weird way to say that, but basically it's more like, it's more ocean neutralization. So you're going down on the base scale, but you're not actually getting into the acid side of the scale. But they will still refer to it as acid acidification, or excuse me, ocean acidification. So just be aware of that. All right. So the oyster larvae, these guys are hurt really bad. That actually is a big thing here in Washington and Oregon. So if basically the issue is the shells of oysters and other sea snails, stuff like that, they can't make their shells as much because they don't have the carbonate ions. It does not necessarily make it so their shells dissolve because they're not really turning into an acid. It basically means that like their shells are dissolving just because that's what happens over time naturally. But they basically, the oyster larvae and the oysters in general don't have the ability to kind of repair their shells or make new ones. So climate change affects wildlife survival rates as well, which is kind of an interesting way to think about that. So if it gets warmer, the insects are going to hatch earlier because they are based on the warmth of the environment. But their predators don't hatch like that. You know, think of like the predators are like birds. You know, the birds have to incubate in their eggs for a certain number of weeks. So it doesn't necessarily isn't judged or isn't changed based on the temperature outside. So if the insects hatch earlier, but the birds aren't, when the birds hatch, there's not as many insects around for them to eat. So the survival rate of birds, those predators, actually goes down. The survival rates of the chicks goes down. Then animals and plants are going to migrate to the cooler areas, so like higher latitudes as well as higher altitude. So basically you can see in the images here, you can see the birds are going to be moving north. Also, the pikas are being forced up slope to basically get to cooler temperatures. Now, another thing that I mentioned there was plants migrating. I know that sounds really weird, but plants are going to move, and they're going to, you know, not necessarily move, but like the success rate of where they basically put their roots and they start to grow, the success rates are going to dwindle where they are, and they're going to be better in different areas, you know, higher latitudes and altitude. But the issue becomes plants and animals can't get too high because there's just not enough air for them. So it's they're kind of running out of places to stay. Next one, forest fires will get worse. And that's pretty straightforward. We've experienced that. We've talked about the fires in Washington, the fires in California. Forest fires are definitely getting worse. Health will also decline. Basically, think about it. If it's a warmer temperature, if humans are outside of basically like our range of tolerance, our metabolic rates will increase. We had that the other day in one of our entry tasks. It was talking about like if the sea temperature is warmer, will marine animals' metabolic rates go up or down? It will go up because they're trying to maintain the same body temperature. So if our metabolic rate goes up, that means our bodies are more stressed, so it's easier for us to get sick. National security will also become more difficult. This is a weird way to think about this, but You can see some pictures with some refugees there. Basically, if refugees are moving to take care of their families, which is a very, very good thing for them, they're basically going to be coming to different kind of the wealthier nations to try and find food and try and find work, which potentially can lead to simply, crime going up because they have to get food, and so they have to steal in order to get it. And that's the part we're talking about with national security. So, economics of this stuff, there's a high cost per year in the future, but there's a big hope that if we invest now, that will hopefully lower the future costs. Basically, we put a whole bunch of money in now. The cost per year in the future will still be there, but if we invest now, those future costs won't be as high. One of the things they're talking about here is just the different impacts of things. So we're talking about the native tribes in Alaska. They can't hunt the way that they used to hunt. We've all seen the polar bears, with Sarah McLachlan pictures. They're not being able to hunt seals as easily. This picture right here is pretty interesting because up in the Arctic, Alaska and Greenland and Russia and whatnot, they build their houses and they build their buildings on the permafrost. But as the permafrost melts, the structure of buildings starts to go away, so the buildings start to crumble. Okay, so you turn the page. Here we go. All righty, so here we go. Continued emission scenario versus reduced emission scenario. So we're basically talking about reducing the emissions, how much the temperature will increase. You can see on the bottom there, temperature change ranges from 3 degrees to 15 degrees. So if we reduce emissions, our country and the planet, we will still rise, but we're going to be rising by, 3 or 4 degrees rather than, 8 to 15 degrees kind of a thing. That's the big change with this. All right.